Alright, let's go ahead and pick up. So this is going to be the review for our geometry. Quarter 3, test 1, so geometry. And we're just going to cover a couple of simple topics today. So remember that we're going to be doing arc length, sector area, how this ties in with circumference, area, and other shapes. So we're going to do, I guess I'll call this mixed shapes, but I'll show you exactly what's going to go on. And then we also have our trapezoids, areas, and midsection. So the trapezoids area plus midsection. And we'll go over trapezoids more over the week, so I'm just going to cover the base so that we have it for the test. But and you can refer back to this video later. Some of this I may or may not have covered yet, but that's okay. Okay, let's start with just arc length and sectors. So these two are going to be heavily related, and in each of these you're going to be given circles, and you're always going to be given a little part of it, and this part can be small, so let's make this one a tiny part. I'm going to make this, I don't know, 40 degrees, and this one over here we're going to make very large, so this one's going to be, I don't know, 160 degrees. Doesn't really matter that much what the numbers are. And we're going to find the arc length. Or actually, I'm so sorry. This will work. Actually, we'll go with this as an example. That's fine. We'll do this one for arc length. And we will do this one for sector area. Speaking of which, if you haven't turned in your worksheets already, make sure to get those in to me, by test day. That way I can have your grades in. In any case, arc length has a simple formula. Theta over 360. So it's the part of the whole circle, whatever part it is, in this case 40 degrees, times, and hopefully you'll remember arc. Arc is that outside part. So arc is that outside part, and the outside of a shape is called the perimeter. In a circle, that's called the circumference. So hopefully remember that the formula for circumference of a circle, or the perimeter of a circle, is 2 pi r. So we're going to go ahead and apply this formula now, where theta is this angle given here. So that angle of 40 is going to replace theta, so I'm going to write 40 over 360 times 2 times pi times r here. And remember, your r is going to be given to you in the problem. I'm going to give it to you now. I'm going to say that r equals, I don't know, let's make r equal to 18. And again, this doesn't really matter what the r is. For this one, I'm going to make the r a really small number just for fun. So that's what that one's going to be. It doesn't matter if it's a large number or small number. Those all going to work the same, so we'll replace r with 18. Alright, from here we're just going to do the math, and I've taught you several ways to do it. For those of you doing it by hand, I'll go ahead and do that one in a second, and I'll show how to do this. But in a calculator, there we go. Okay, so in a given calculator, and I know that the focus is kind of bad on the calculator here. Let me see if I can't. Okay, well, everyone's calculator is a little bit different, so it really depends on which calculator you're using. I've worked with some of you, but to do it by calculator, what you're going to do is you're always going to take this top number and multiply by the 2 and whatever your radius was. So 40 times 2 times 18. So 40 times 2 times 18. And you're going to hit equals or enter or whatever else, and then you're going to divide by this bottom value. So divide by 360. And you're going to get 4, and at the end you're just going to tag pi onto your answer. So this is just going to be 4 pi. Okay, and that was how to do it by calculator. So you just multiply the top of the fraction times the 2 times the r, and you'll get a number, divide by 360 at the end. Tag on pi. Okay? The way to do it by hand is like this. So let's pretend we don't know the answer. And if I were to simplify this, what I would want to do is I want to simplify the fraction first. We've already done fraction lessons. I'm not going to go over exactly how to simplify, but that simplifies down to 1/9. You can also use a calculator to simplify a fraction. So if you wanted to do it that way, 40 divided by 360, it'll give you a decimal. And then you're just going to go ahead and press your conversion button. On different calculators, it's a different button, but it typically will say like S to D or F to D or something like that. So you'll notice that, oh, you can't see that. Mine is down here, so I have to hit second and then this button, and then it'll change it over to 1/9, which I just told you it's already 1/9. So again, you can do it with a calculator, you can do it by hand. There are a lot of different ways to handle this kind of problem. So still times 2 times 18 is 36 pi. All right, and then 1/9 times 36, 36 divided by 9 is 4. So you'll still end up with 4 pi. So this is how you do it by hand. We showed how to do it by calculator. If you're not comfortable with these things, you really should be practicing them. This is something that you must be able to do on your own. Okay, so let's go ahead and do sector area. Sector area is going to have a different formula. It's still theta over 360, because sector area, keep in mind, so sector area, while arc length was this entire outside, sector area is the whole inside. All this. Okay, so while the arc length is like the crust of a pizza or the crust of a pie, sector area is the whole slice. Okay, so theta over 360 times, and hopefully you'll remember, especially since it's called the area, sector area, so the area of a circle is pi r squared. That was a really sloppy pi, but it's okay. We'll just plug in our values. So theta on this problem is 160. So we'll plug in 160 over 360 times pi. And then r is 4, so it's 4 squared. From here, you're going to go ahead and work out the problem. So I'm going to do it by hand first this time, and then I'll do it in the calculator. It is easy to do in the calculator, but it's okay. We'll just simplify a little bit. 4 goes into 16 and 36, so you'll end up with 4 over 9. And then 4 squared is 16, so this is like 4 over 9 times pi times 16. 16 times 4 is going to give us 4 to 64 over 9. And then we'll just go ahead and tag pi on. So again, all I did was I multiplied 16 times 4, which gave you 64, and then it's still over 9, and then times pi. Okay? So that's how to do it by hand. Like I said, I've already worked fractions, so I'm not redoing that lesson. To get this same answer here, again, you can get your calculator out, and you can just press in 160 divided by, or I'm sorry. So for this one, it's a little different. So 160 times, and you'll have to do this depending on your calculator 2 different ways. So 4 squared, if you just know it's 16, that makes your life easier. Just type in 16. But if you don't know, then you may want to do the 4 squared first, because remember, we still want to follow PEMDAS, and the exponent should be done before multiplying like this. So before I take the 160 and multiply by this, I really should do the exponent first. Remember PEMDAS, okay? So anyway, so 160 times 16 will hit equals, divide by 360. You'll get a decimal again, and then we can hit our F to D button, and it'll change it for us to, and you'll notice that's 64 over 9, just like we had down here. So that doesn't change it. Again, you always multiply the top number by whatever other numbers you have, and then divide by the bottom number at the end, okay? Anyway, that's how to do both of these with a calculator or by hand. That's completely up to you which style you want to go with. If you don't have a calculator, obviously you're going to have to do it by hand. So if you don't have a calculator, you should be really good with fractions. On the test, I'll have questions where it says that I want my answers in fraction form or in decimal form. It'll tell you where to round. So if you're going to, write the decimal answer, just make sure that you're following directions, okay? Anyway, that covers both of those topics, so let's go ahead and move on to our mixed shapes. Now, there are a couple types of mixed shape problems that are going to show up on the test. Let's see, and they'll look like this. We're also going to include some slightly more complex parts, but you'll get a shape like this. And none of these are drawn to scale. I'm not going to write that disclaimer on my test, but just know that everything that I draw is not to scale because, well, my hands aren't that good. So, God, that's really bad, but A, B, C, D. So it'll tell you that this arc here, arc AB, is a semicircle. And remember, semicircles are half circles, so that means that they measure 180 degrees. And then it'll give you some values, like, I don't know, BD, we're going to make 6, just because we can. And all of these are 90-degree angles, so there you go. So it'll say AB, and then it'll say like square ABCD or rectangle ABCD. So in this case, I'm going to call it square ABCD has, BD equals 6, etc., etc. So the problem will be set up for you to where you just have to understand what the shapes are and how you're working with them. And then you're going to get a problem like this where it could ask you for one of two things. It's going to either ask you for the area or perimeter. And we can do both. We can do both. So let's work with let's work with area here first because it's over on the left. So let's find the area of this shape given this information. Okay? And you'll notice that there's not a whole lot of information, but it'll be enough to work with. So the area is going to be all the inside. So I need to work with area formulas. The first area formula is the area of a square. Hopefully you remember the area of a square or a rectangle is, so area of a square or a rectangle, honestly. So it's technically length times width. For squares, so for squares specifically, it's side squared. Because the length and the width are the same. So I know the BD is 6. So let's go ahead and draw that in. I'm going to draw that in red to show that like it won't be in the problem, but you can add this. You can be like, all right, well, that's 6. That means that that's 6. That's 6. And this is also 6. Okay? You can also mark that that's 180 if you want, if it makes you really happy. Okay? So you can mark all this information in for yourself to make it easier, but we know that area is side squared. So let's find the area of the square to start. And with area, so you want to, with area, so when finding area, and if you're studying or writing notes, this is a good thing to note. I've said this before in class, but I didn't write it out. When finding area, you need to find the area of each shape and add them all together. So it's not really difficult, and add them and sum them. Sum up. So that really just means and add them all together, but I didn't feel like writing all that. So sum up. In any case, you just need to know the different formulas for the different shapes. So I'll tell you the different shapes that we'll be working with. It's just going to be squares, rectangles, and triangles. So you're either going to use side squared, and hopefully you have this all in your formula sheet, but remember that triangles, let's just write this on a separate sheet of paper. Area of a triangle is 1/2 base times height. And area of a rectangle is length times width. Area of a square is still length times width, but you can also call it side squared. And then area of a circle is pi r squared. There we go. Okay, so if you need your area formulas, just memorize them. Those are the only shapes that we'll be working with mixed shapes for now. I know that we just did trapezoids, but I haven't done mixed shapes with trapezoids, so it's not going to be on the test. So in finding area, find the area of each shape. So let's find the area of the square first. Remember, square is just side squared, so 6 times 6 is 36. I don't know why it is in this class that I keep picking 6s, so I'm sorry for anybody that really freaks out. 6 is just a really nice number in mathematics to work with. In any case, the area is going to be 36 for the square. So this is the area of a square. Okay, but you're missing a part of the shape. So you found this entire area. So this whole square, we're all good. But what about the half circle? So a half circle, we can use our area formula. But remember, it's only half of it. So it's 180 over 360, which simplifies to 1/2. So let's find the area of our the semicircle. So our theta over 360 times pi r squared. Okay, theta is 180 over 360. And remember, it's a semicircle, so you know this simplifies to 1/2. You could skip this entire step and just write 1/2, but that's up to you. Pi, and then our radius. So remember, with this shape, the radius is not 6. 6 is the whole thing across, so you have to remember that radius is half of that. So the radius is just 3. Okay? Radius is 3. And then we do our math. You can do this in a calculator, but this is really just half of 9. So I'm going to say 9 over 2 pi. Because 3 times 3 is 9, and this is a half. So 9 times 1/2 is 9 over 2, and then pi. Again, you can do this in a calculator if you had to. And what you're going to do is you'll probably need a calculator for this, because what I'm going to do is I'm going to ask for these answers in decimals, and you're going to need to compare these two areas. So the area of the square is 36. The area of the circle is 9/2 pi. I need to add these two values together. To do this in a calculator, 9/2, and then pi. Normally there's a pi button on this calculator. It's up here. So most of you guys will have to press like second, and normally a button somewhere in this area, sometimes down here. It really depends on the calculator, so if you're not sure, just ask me on test day. Hold on, let me do that, and then times pi. I'm not sure how specific this calculator is about that. Yep, sorry. So times pi equals that. And if you don't have a pi button, or you just can't figure it out, you can always do 9/2, it equals, and then times 3.14. It won't be exactly the same, but you'll notice that we have like 14.137. Well, it's 14.13. It's pretty close. And that's fine. So if you ever need to use 3.14, I'm not going to bother with it. As long as you're within one decimal place, I'm okay. So we'll use 14.13, and then you're just going to add it to the 36 for the square, because that's your area of a circle. So we'll just add 36, and that's your total one. So 50.13. So the area of the shape, so area of shape is 50.13. Okay, again, you just found the area of the square, the area of the semicircle, and added these two numbers together, which gave you roughly this. So I should make these squiggly there. Okay, so that's the area of that shape. Now if we wanted to do perimeter is actually a little easier to find perimeter. So area, you have to find each individual shape, and it's a couple of steps. But perimeter, you just need these outsides, and because it is a square, you already know that one's 6, that one's 6, that one's 6. So we just need the semicircle. Again, we'll use our formula. So arc length. So arc length, I don't know why I drew a circle there, is theta over 360. I think I was trying to draw theta and I forgot, times 2 pi r. Okay, so arc length is theta over 360 times 2 pi r. And we'll just fill in our values. Again, theta is still 180. We still know that this whole thing's going to simplify to 1/2, but I'm going to go ahead and write it out. 2 pi, and remember our r was 3. So this is 1/2. This is 1/2 times 2 times 3 is 6 pi. So half of 6 is just 3, so you just end up with 3 pi as your arc length. And again, you can use 3.14 if you want, so if you have to do this in a calculator, 3.14 times 3, times 3, well, it equals, and then don't forget to add it to the rest of your values. So add 6, add 6, add 6, so add 18. 27.42. So this one, the perimeter is 27.42 roughly. Okay. And again, if you're within one decimal place, you're going to be fine on the test. So that's how to find area or perimeter of a mixed shape. You just have to determine what the shape is. On your test, you will have one that's a square. You also have one that's a rectangle, and you also have one that incorporates a triangle. So hopefully you understand that. All you have to do, finding area, find the area of each shape, and add them all up. To find the perimeter, just add the outsides. That's all that is. Okay? So that covers arc length, sector, and mixed shapes. So let's go with trapezoids, our very newest area. I'm just going to write it down here. And I know I'm going through this quickly. Feel free. I think YouTube does like half speed, so you can probably just slow this down if you have to. Rewatch it, pause it, rewind it. But most of the important part is that you have to do this on your own. So, two basic things. So area of a trapezoid. Area of a trapezoid. Oh my gosh, that's one of the worst trapezoids I've ever drawn, but whatever. Is 1/2 base 1 plus base 2 times height. You'll notice that this is a lot like the triangle formula. It looks very, very similar, except now there's a base 1 and base 2 instead of just base. Okay? And remember, in a trapezoid, doesn't matter what kind of trapezoid. This one's not even isosceles, it's just a trapezoid. But base 1 and base 2 are the tops and the bottoms. So these flat parts. So this is base 1, base 2. And it doesn't matter. You can call the top base 2 if you want, the bottom base 1. I really don't care. It really doesn't matter because I could also draw the same trapezoid like upside down. Well, whatever. It's not exactly the same, but I could call this one, you know, base 2, base 1, or base 1, base 2. It really doesn't matter. So it's completely up to you which one you call what. There's just the top and the bottom of this trapezoid. So those are those two. So the base 1 and base 2, those are just the top and the bottom. The height is always the distance from the bases. So it doesn't matter if I put the line here, put the line here, you know, put the line way over here. It's all going to be the same. They're all going to be your different heights. They're all going to be the same height. So the distance is the same no matter where you do it on a trapezoid. Okay? So let's start with a simple trapezoid like this one. So I'm going to go something like that. And we're going to make the height 2. Base 1 is going to be 8. Base 2 is going to be 4. All right? Wait, that doesn't make any sense. Let's make this one 8 and that one 4. Because that one's obviously shorter. You know, sometimes I'll use weird numbers. If it seems wonky to you on a test, just point it out and I'll explain, and maybe I'll have screwed up like my numbers in my drawing. But my excuse is just going to be, well, remember, not all figures are drawn to scale. That's a really bad excuse for a lot of these. I probably just didn't notice that I drew it weird, but in any case, let's go ahead and apply the formula. So 1/2, so 1/2 base 1. So base 1, remember, is either the top or bottom, doesn't matter which one. If you want to make the top base 1, let's go ahead and do that. Plus base 2, so if base 1 is the top, base 2 must be the bottom, times the height. And the height here is just 2. Okay? So 4 plus 8 is 12. And we're just rewriting everything else. 12 times 2 is 24. And half of 24 is just 12. Okay, so the area of this trapezoid is just 12. It's a pretty simple idea. I'm going to show you one more example where you have to do a little extra work to figure it out, but it shouldn't be too bad. All right, so again, we're going to use the same formula, but we're going to have a different type of problem. So here's a trapezoid. Let's make it like, I don't know, like that. And again, it's a trapezoid. I'm going to draw this little height thing. And they're going to tell you that this is, I don't know, let's make this 9. I'm going to make this 12, 15. Yeah, sure. Let's make that 15. And then this one will be, oh no, I keep using all of my special values. Let's make this one 20 and this one 15. There we go. Okay, there. Now given this one, you'll notice that I'm given base 1. I can figure out base 2, but I'm not like explicitly given it. And then I know my hypotenuse, but remember, this is slanted. It is not the distance from one base to the other. Okay, so this dashed line, this straight up and down line, that's our height because it goes from base 1 to base 2. This one here is a slanted line. It is not the shortest route from base 1 to base 2. This is called the hypotenuse, but it is not a height. Okay, so we're not given height here. So remember, our formula is 1/2 base 1 plus base 2 times height, and we're missing some information. Let's go ahead and see if we can't come up with some stuff. First off, we actually know how long this is. Oh, well, technically no we don't, but if I tell you these are 90, you're fine. There. So, given this, I know now that this side here, and if I assign them names, A, B, C, D, E, whatever. I made this really weird, but from AB to CD, these two must be the same, so that must mean that CD is also 20. Which means that my base 1 is 20. That's fine. But what about my bottom part? My base 2 is not 20. It has to be the whole thing. But that 20 only goes from here to here, from C to D. But what about C to D and to E? So 20 and 9. So you're going to have to add those up. So now we know that it's 1/2. 1/2. And then base 1, again, is 20. That's pretty obvious. But base 2, we're going to have to do 20 plus 9, so it's plus 29. And let's go ahead and find the height. The height we don't know yet, so we still don't know height. Height is missing. So we're going to have to find that. To find height, we look at this, and this should be a shape that you're used to. This is a triangle. Okay? And triangles that are missing a third side use the same formula every single time. So right triangles that are missing that third side, we're going to use Pythagorean theorem. A squared plus b squared equals c squared. C is always a hypotenuse, okay? So if we have our hypotenuse, 15, we're just going to plug it in. So instead of c squared, I'm going to write 15 squared equals, and it doesn't matter which one, a or b squared. If you want to call this b because it's the bottom, go ahead. If you want to call it a just because, go ahead. I would just always fill in the same one, so I'm going to replace a just because that's what I feel like doing. And then we don't know b squared, so that's fine. We're going to get it later. Okay, we're going to get it later. I don't know why I did, whatever, my color scheme's all messed up. But anyway, 9 squared is 81. 15 squared is 225 equals, so plus b squared. And we'll just go ahead and subtract 81 from both sides. 225 minus 81. I'm just going to type it in a calculator. I don't really feel like doing it in my head. It's 144. Oh, well, yeah. Oops. Anyway, b squared is 144. And then you have to remember, get rid of that square. You have to square root both sides. And the square root of 144 is 12. So b is 12. That means that this side here, this height, must be 12. Now you have your height. So we can just plug that in here. So now it's 1/2. 20 plus 29. But you now know the height, which is 12. Let's go ahead and just add these numbers. So 49, so 1/2 times 49 times 12. And these are pretty big numbers, so I'm going to go ahead and use my calculator here. And all you're going to do is you're going to take 49 times 12. It equals, and then divided by 2. So it's 294. So our area of this trapezoid is 294. And again, this could be whatever unit. So if I said that all of these were like centimeters, etc., then this would be centimeters squared. All area units are always squared. We already know that, but you know, whatever unit they are. Okay. So hopefully that makes sense. Hopefully nobody's having too much trouble with that. This one is the same. Okay, it's the same. The one step was that we didn't have height and we didn't have our base 1, our base 2 just explained us. So we had to do a little addition and then we had to do Pythagorean theorem. You are going to get questions like this on your test. Okay. Now that covers area of trapezoids. The very last thing that I want to cover real quickly is midsection, and you're going to see a couple of midsection type questions on your test. We're going to cover it more in class before the test, but midsection is this. Remember every trapezoid. Oops. Well, pretend this doesn't exist. Every trapezoid can be given a midsection. So if I tell you this is the midsection, so this is A, B, C, D, E, F. So if I tell you that FC is the midsection, we know something very specific. I know that the top line, or base 1 and base 2 added together divided by 2 equals FC. The reason for this is because FC is the midsection, so it is the average of the other two. So basically the top, I'm going to call it base 1 plus base 2 divided by 2 equals your midsection. This is the way we described it in class, okay? If you have to, think of base 1 and base 2 as the top and the bottom. So add the top, add the bottom, divided by 2, and that gives you your midsection here. All right, so let's apply some numbers. Let's go ahead and give some values. Let's say that AB is 10 and ED is 30, something like that, okay? And so these numbers are going to work out really pretty. Let's do it. And we need to find FC. So we don't know what FC is. What's FC? Okay. So FC is, we don't know. But we're going to find out. And all you're going to do is you're going to go, okay, well, what's base 1? 10. What's base 2? 30. Oops, sorry. And then this is all over 2. So 10 plus 30 is 40. 40 cut in half, or 40 divided by 2, is just 20. So FC must equal 20. It's a really, really simple formula because, again, you're just adding two numbers, the top and the bottom, and then dividing by 2. It gets weirder when I start giving other missing values, but it's really no different. Like, this is not a hard kind of problem at all. It's going to remain the same, so you just need to practice this. And what I highly recommend for your practice is take any of the problems in this video, or just draw a trapezoid and pick some random numbers and put them somewhere on the picture. That's pretty much what I've done. So on your test, you're also going to get a problem that looks like this. So here's a trapezoid. And again, on all these trapezoids, on your test, they're going to be marked and notated like that, but I've just not really been doing it. So there you go. So again, we'll just make it the same letters: A, B, C, D, E, F. And FC is still the midsection, okay? And we're going to go ahead and calculate some values. But here's the thing. Instead of that, I'm going to be giving you that this is, I don't know, 30, and this is 50, okay? And I need you to find AB. So AB is unknown. Don't worry, this problem still works out because you're going to use your midsection formula again. So your midsection formula again is B1 plus B2 over 2 equals the midsection. Okay? So let's talk about it. B1 is the top, right? So I've always made B1 the top. If you want to call it the bottom, you're fine. But I'm going to pretend B1's the top, which is what you guys did in class. Now, I don't know what the top is. I'm not sure. So we're just going to leave it B1. Okay? Plus, what's B2? So B2 is the bottom. That's 50. The formula says over 2, so we're going to still put it over 2. And it equals the midsection. So this time I know what my midsection is. I know it's 30. And we're just going to do the math. You're going to multiply by 2 on both sides. So B1 plus 50. So remember, we multiplied by 2. Looks like this. Okay? And the 2's will cancel. And 30 times 2 is 60. To get B1 all alone, I just need to get rid of plus 50. To get rid of plus 50, we subtract 50. Ooh. Okay, well, that's kind of sloppy. But B1, 50 minus 50 is 0. And then 60 minus 50 is 10. So B1, way up here, must be 10. And that's all you do. So it doesn't matter which one I give you. You can solve for all of them as long as you're given 2. I have to give you 2 numbers. If I only give you one of them, yeah, you're screwed. Nothing can happen. You have an infinite number of answers. But as long as I give you 2 of these numbers, you're fine. Okay? So let's go ahead and go again. We're going to go one more type of problem, a little bit harder. Well, I don't know. It's really not that much harder, but here's the trapezoid again. And you'll notice I keep drawing the trapezoids in different ways. Yeah, so I keep drawing all of my trapezoids in different ways. There's no real reason for it. It's just that you can. So I'm going to use different letters this time. I'm going to use like L, M, N, O, P, Q. So this time you'll notice that my midsection is QN here. That's an N. Wow, that's really bad. N. Okay, so QN here is our midsection. And I'm going to give you some new values like x plus 2, x minus 8 equals 12. Or we'll make this x plus 8. Okay, so this kind of problem, it looks kind of weird. Now I'm given a lot of different values, but what I need to do is solve for x. Solve for x. Okay, so let's solve for x. And what you'll do is you'll still apply our formula. Remember our formula again, base 1 plus base 2 over 2 equals the midsection. So let's go and apply it. Base 1, the top, is x plus 2. You've still got a plus sign. And then let's add base 2, so the bottom, x plus 8. All over 2 equals the midsection, so that's 12. Okay. And just like before, so to get rid of this divided by 2, and the step that we kept using in class and everyone wanted to use as step 1, let's go ahead and use it as step 1. Multiply everything by 2. Because those 2's are going to cancel, and you're just going to be left with what's on top. So x plus 2, plus x plus 8 equals, what's 12 times 2? Hopefully you'll remember, that's 24. Let's combine some like terms. So 1x plus 1x is 2x. 2 plus 8 is 10. still equals 24. Get rid of that plus 10. So to get rid of the plus 10, you have to subtract it. Remember, we always do the opposite. 10 minus 10, 0. 24 minus 10 is 14. From here, you just got to get rid of that 2. So that's 2 times x. The opposite of multiplication is division, which will give me x equals 7. Okay, so that's that entire problem. It's the same as everything else. It uses the same formula. It's just that now you've got some x's involved. But you should be able to add these basic x's. The problems don't really get any more complex than that. So that covers everything that we're going to be covering on the test. Again, let's just go ahead and do a quick summary. You're going to be doing arc length, sector, which are these two. Mixed shapes, which is like this one right here. Okay, mixed shapes. Remember, area and perimeter of mixed shapes. And then midsections, which can be like this one, where it's just basic, top and bottom, add them together, divide by 2, gets that. Okay, or you might have to solve something. Might look a little more like, where's that one that I just did? Oh, no. Oh, there. Okay, or it might be a little more complex like that, but that's it. So just those 4 different topics, each of them are broken into little subsections, but you guys should be fine. Hopefully everything makes sense. Make sure to review over the weekend. You guys don't have your test until Wednesday, so you'll see me more in a bit. All right, I'm going to go ahead and close this out. Best of luck, happy studying, and I will see you guys on Monday.